Let's begin. Today is May 17th, 2024, and we're doing the Daily Turing Machine Puzzle. Today's puzzle uses 5 criteria cards and it's 5 verification cards. Let's go to turingmachine.info for the details. So today's puzzle has criteria cards 2, 6, 13, 17, 21, and uses the blue verification cards. Above, you have the unique identifier in case you ever want to look this up. Let's go solve. So on our grid above, we've got our 5 criteria cards. On the top row, we've got criteria card A, criteria card B, and criteria card C. In the second row, we've got criteria card D, and finally criteria card E. So let's look at criteria card A. A looks at the first digit, the triangle, and compares that number to 3. So should the triangle be less than 3, equal to 3, or greater than 3? Criteria card B will look at the middle digit, the square, and let us know whether that digit should be an even number or an odd number. Criteria card C compares the second and third digit, the square and circle, and basically will let us know whether the square should be less than the circle, should they be equal, or should the square be greater than the circle. Criteria card D will let us know the number, the quantity of even digits in our answer. So should there be no evens? Could there be 1, 2, or should they all 3 be even? And finally, criteria card E will let us know if there is a pair of digits in our solution, as in the example 131, the digit 1 is repeated. Or, on the flip side, will there be no pair, as in the example of 134, which has all unique digits, no repeats, or potentially it could be that it has a single digit repeated 3 times. So remember, our objective is to find that one unique code that meets all the criteria that we just discussed. And I start with my initial proposal of 314. So I'm going to start by testing criteria card B and find out whether that middle digit is even or odd. Okay, so the Turing machine approves. So if I go back and look at my proposal, notice that I chose a 1 for square. Well, since my proposal digit was 1, that means that the Turing machine is letting me know that yes, that middle digit is odd. So that's what I'm going to write down in my notes. So for criteria B, we know that square is an odd digit. So I'm going to go up here and eliminate and cross out all the even digits since they are no longer valid. Okay. Now, it doesn't mean that my solution is going to have a 1. The Turing machine just is letting me know that yes, the middle digit needs to be odd. It still could be 3 or 5 or even 1. Let's see, what else can we test? So we do know that we have 1 odd digit here. So obviously there can't be 3 evens. There could be a potential for the other 2 digits to be even, 2, or potentially 1 as I have it, or none. I think before I test the quantity of evens, let me find out whether there's a pair or not a pair. So let me test criteria card E. Okay, so the Turing machine does not approve. Notice that in my proposal of 314, that is a unique, it uses all unique digits. So the Turing machine says, nope, that can't be. So that means this whole category is invalid. So in fact, there is a pair of digits. So that's what I'm going to write down for my notes in criteria card E. So I'm going to state that there is a pair. Okay, so at this point, I don't know if it's 2 odds or 2 evens. So let's see. If I go back, and of course I can't eliminate anything at this point, If I go back to my even card, again, we know that there can't be three evens. If the Turing machine says yes, then I do have a pair of odds and one even. If it says no, then either they're all odd or there is a pair. I think I'm going to go with that. I'm going to try criteria card D and see what happens. Okay, fantastic. So the Turing machine approved. Again, looking at my initial proposal of 314, I have one even. The Turing machine says yes, there is one even. So that actually worked out. So I'm going to say in here, there is one even digit, and I'll say and a pair of odd digits. Okay, so remember, we did establish that there is a pair. Since there's only one even, those odds are gonna pair up. So at this point, all I know is that, again, either triangle is the even or the circle is the even, and the other one is going to be the paired up odd. So that will make for an interesting second proposal that we need to construct, knowing what we know. Okay, so if I look back, what have I not tested? I've not figured out what A is, the triangle. C, comparing the second and the third digit, and that's it. So again, these two remaining criteria cards need to lead us to the right answer. And again, there's only a unique solution. So what can we, if for example, maybe square and circle were equal, right? That would help us out. But at the same time, and they'd be equal, they'd be both odd. There's nothing else there to tell us what they should be, right? Could they both be 1, 3, or 5? I don't see anything in our criteria cards to figure that out. So I'm going to deduce that the circle has to in fact be the even digit. And then it's going to be the criteria A that'll tell us which odd it should be. Should it be 1, 3, or 5? That's what's going to determine triangle. And because it's paired up with square, that's going to be the square as well. And the circle will be dependent on what, triangle is essentially, because it kind of bubbles down from triangle to square to circle. Okay, so that said, I need to somehow, again, I've eliminated or deduced that it can't be equal. So either square is going to be less than circle or greater than circle. And so we almost have to force the issue with circle. So that means that if I pick, 3, then one way or the other it's going to be 1 or 5. I'm sorry, I apologize. I'm thinking it's going to be even, so it's either going to be 2 or 4. Otherwise, let's see. I don't think it can be 5. So it can't be 5, 5, because then, of course, 1 and 3 or 2 and 4 are both less than 5. And I don't think it can be 1 and 1, because then 2 and 4 are greater. So I'm thinking that triangle has to be 3. So I think it's going to be 3, 3, and then either less than or greater than. So it's either 3, 3, 2 or 3, 3, 4. And I don't think I have enough information. So I'm just going to say let's do 332. Okay, let's give that a try. Now, I do want to test C first, only because, I feel confident about the 3, but I'm not sure. So let me test C first, and let's see what that tells us. Okay, so it's not correct. Again, look at our proposal. It's not correct that square is larger than circle. So that means that square has to be less than circle. So I'm going to come up here and say square should be less than circle. Now, again, that's based off of my, deduction that, in fact, circle cannot be the odd, because that does not tell me enough information of what they could be. So that's sort of my deduction. I've eliminated the equal. The Turing machine has eliminated the square is greater than circle, so that means square has to be less than circle. At least that's what I'm going with. And so based on what I do have so far, if square has to be less than circle, then square cannot be a 5. That's too big. And circle can't be 1. Okay, so again, my deduction is that circle has got to be 2 or 4. And again, if square is 1, obviously they're both 2 and 4 are both, or 1 is less than both 2 and 4. So that makes no sense. And so it would have to be 3. So I think I'm making it official. I'm stating that triangle and square have to be 3. So I'm gonna cross out the 1 and leaving my 3 for square. I'm then also going to say that triangle is 3. So I'm taking a bit of a gamble, but I think the logic is sound. So 3, 3, and then because square has to be less than, it should be a 4. Okay, so I'm going with 3, 3, 4. So here I'm going to write down, I'm just going to deduce that triangle is equal to 3. Okay, and again, because triangle is equal to 3 and it's paired up with the square, that is also 3, and of course we've got square is less than circle. All right, so I'm saying that my final solution is going to be 3, 3, 4. Okay, so it looks at, based on all the deduction, that's what the answer should be. All right, well, let's go test against the Turing machine. So 3, 3, 4. All right, so verify code or test code 3, 3, 4, and verify. Awesome. Okay, so those deductions really paid off, and I'm really thinking that, I only did, I believe, in 4 tests. So let's see how we did versus the Turing machine. So the first proposal, I tested B, D, and E. So B, D, and E. D and E. And E was wrong. And in my second proposal, I tested C and it was incorrect. Okay, let's see how we did versus the Turing machine. Okay, wow, that's rather impressive. So we did it in 2 turns, or 2 rounds with 4 questions, and the Turing machine took 3 rounds and 7 questions. Okay, so again, looking back, just thinking through some of these potential solutions, again, trying to play and figuring out which of the triangle and circle could be even or odd, and just play with it and see if you can come to some sort of conclusion or some way to kind of figure out, well, no, that doesn't seem like it's plausible, so then you change your deduction to something else that makes a little more sense. Well, I hope today's puzzle was enjoyable. It certainly was for me. And if you have any comments, please write them down so that others can know what you're thinking. And if you did like the video, please give it a thumbs up. And if you want to be notified for tomorrow's video, please subscribe, and you'll find out when the next video is available. All right, great. Thank you very much. Have a great day, and we'll see you next time.